Alrighty. So do we have an explanation about why atoms become ions? Say again, Sarah?
They react unequally.
Why is it that they want to become ions?
They want to become
There's
stable.
not even number of protons and stuff.
It's not that they want an uneven number of protons and electrons, but once they do have an uneven, they are automatically ions. But the reasoning behind them initiating losing or gaining electrons has to do with what?
Becoming
They're
stable.
outer orbital, they want it stable.
They want stable electron configuration, right? They're trying to look like a noble gas. So if you've got the most simple 1s2, 2s1 lithium, if it gets rid of this one electron, then what's left is helium's electron configuration. And once that electron's gone, what's changed about this lithium is this thing still has 3 protons, but now it only has 2 electrons. So its overall charge is going to be a +1 because all of the positives are not neutralized by all of the negatives. So they're becoming ions because they want to have noble gas configurations. And they do that by adding or subtracting electrons to their energy levels. Why does an atom that has reacted no longer have the ability to react?
Because they're
Now they're stable, right? So if we use this one here as an example, our lithium that's already reacted, 1s2, whose electron configuration is that? 1s2.
Helium.
This is helium's electron configuration. Is this thing reactive?
no.
No, it's inert. One more time. It's inert. So you're not going to get that thing reacting. Once the sodium has done its little explosion thing in the water and caused it to catch on fire, now I just have sodium ions that have the same electron configuration as neon. And neon doesn't react, so now it doesn't react. Which element is more likely to gain electrons, silicon or bromine?
Bromine.
So why the bromine? So I've got silicon and I've got Br. What's the reasoning behind it?
Bromine only needs one to be a krypton, or to look like krypton.
Okay.
It's
So
halogen and
this is one needs one. And what's this guy's situation? Needs to gain or lose 4. So it's a lot easier to gain 1 than it is to gain or lose 4. There's a super easy way to figure it out. It's the same way we figured out something else on the last homework, which is what?
what I was just saying, get the atoms.
Easier than that.
How far away does from fluorine?
How far away you are from fluorine. Because this question is asking about most likely to gain electrons. So what's the atom that's most likely to gain electrons? Fluorine. The closer you are to fluorine, the more like fluorine you are. So bromine is much closer to fluorine than silicon is. And remember what we said if they're both equal distances away?
Well, that's next to the one to the left.
No?
The one that's in a higher row.
How do we say that easier? The easy way to say that? The smaller one.
Oh.
So bromine and nitrogen are equal distances away from fluorine. Are we okay with me saying that? They're both 2 blocks, 2 elements away. Bromine is straight down by 2 and nitrogen is over 2. Fine. So which one of those is more reactive? Since they're equal distance away, we have to choose nitrogen because it's smaller. How many protons and electrons are found in the sulfite polyatomic ion? So what's the formula for sulfite? SO3 minus 2? Okay. And so how many do we have for sulfur? 16. And then for oxygen?
24.
Well, how about 8
8
times 3? 24, I'm okay with that, but it's 8 times 3. So 24, 30, 40. So we've got, whoa. Are we done? So we've got 40 protons. We okay with that? You can always get the proton number no matter what, because whatever the symbol is, that's telling you how many protons are there, and that number cannot change. So what do we know about the electrons?
There's 2 extra.
There are 2 extra. That's exactly how you used to think about it. I've got 40, and all 40 of those protons have been neutralized by 40 electrons, plus this thing's -2, so this thing must have 2 extra electrons. So we've got 42 electrons on a sulfite. All right, so what is an ion?
An atom that
A
has
charge.
a different, like one less electron than proton or one less proton than electron.
How about that? Are you okay with me saying that? An unequal number of protons and electrons. It doesn't matter if I've got more protons or more electrons or less protons, however you want to say it. The proton-electron number, they're not equal to each other. And in doing so, what you end up with is a charged particle. If you don't know what the 3 dots means, that's therefore. So if you've got an unequal number of protons and electrons, therefore you've got a charged particle. Molecule, how about that one?
A group of atoms.
How about 2 or more atoms bonded with a neutral charge, meaning there are no positives or negatives, meaning that particular molecule, if I counted up all of the protons and all of the electrons in the molecule, those 2 things would be equal to each other. Cation, what's this one?
Positive charged ion.
So positive charge are extra protons, negative charge, extra electrons. Why would lithium be happy to form a compound with bromine?
Lithium wants to give away one electron and bromine wants one.
Yep. Each of them satisfies each other's conditions to look like a noble gas. Lithium will look like helium, and bromine will end up looking like krypton. What's lithium's electron configuration before and after? So it's 1s2, 2s1, and that turns into 1s2. And so then bromine's is 1s2, 2s2, 2p6, 3s2, 3p5, no, 3p6, 4s2, 3d10, 4p5. And it turns into 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. So we end up, that 5 right there changes to that 6, and this 1, there isn't there, disappears. So this 1 electron that's in the, that was right here, is now the electron that's right here. Okay. Do we have any questions about that?